Hi guys, myself Sadashiva Amar. Today let us discuss about the introduction to the breadth first search. Breadth first search is a graph traversal algorithm used to explore all the vertices of a graph in a systematic manner. It starts from the root node and explores all the neighboring nodes at the current depth prior to moving on to the nodes at the next depth level. Defining and purpose of breadth first search graph traversal. BFA systematically explores all the vertices of the graph to find specific nodes or paths, shortest path. It is often used to find the shortest path between two vertices in an unweighted graph, minimal spanning tree. BFS can be used to find the minimal spanning tree of a connected unnamed. How breadth first search works. Queue based. BFS uses the queue data structure to keep track of all the vertices that need to be explored. Visited nodes. It maintains a record to visited nodes to prevent revisiting the same nodes and to avoid the infinite loops. Level order traverse. The nodes are explored level by level, making the BFS suitable for finding the shortest path. Pseudocode for the breadth first search algorithm. Q is equals to new of Q. Mark source nodes S as visited. Q dot NQ of S. While Q is not empty, do V is equals to Q dot DQ. For each neighboring U to V do. If U is not visited, then mark U as visited. Q dot N U Q of Q. Pseudocode for the breadth first search. Initialization starts the initializing the queue and an array to keep the track of visited nodes. NQ and the DQ. Add the starting nodes to the queue, then DQ a node, visit the neighbors and the NQ them. Termination. The process continues until the queue is empty and all nodes are visited. Time and space complexity of breadth first search. 0 of V plus E time complexity. The time complexity of breadth first search is O of V plus E, where V is the number of vertices and the E is number of edges. V is vertices and E is edges. O of V space complexity. B of breadth first search as the space complexity of O of V, as it only requires the space for the visited nodes and the queues. Applications of the breadth first search. Shortest path and minimum spanning tree. Used in finding the shortest path and a minimum spanning tree in an unweighted graph. Network broadcast. Efficiently finds all the nodes reachable from a source node in a network. Web crawling. Utilizing the search engines to index web pages by crawling from the root page. Advantages and disadvantages of breadth first search. Advantages. Guarantees to find the shortest path in an unweighted graph, suitable for peer-to-peer media, streaming and copying detection. Disadvantages. Not efficiently for weight graph or large-scale networks. Uses more memory compared to the depth first search in the worst case scenarios. Conclusion and the key takeaways. Effective graph exploration. BFS is a valuable tool for systematically visiting and exploring all the vertices in a graph. Resourceful algorithms. It have various particle application in different fields like computer networks, data mining, and the Informatics. Conclusion. Effectiveness. Breadth first search is a versatile algorithm with diverse applications and the balanced time and the space complexity. Critical analysis. It is essential to assess the suitable of BFS based on the specific graph structure and the structures and search requirements. Thank you.